Hello everyone and welcome to Group 10 presentation. Group members are Arpit, myself Preeti and Gursimran. Today we are going to present a paper on trustworthy AI in the age of pervasive computing and big data by Abhishek Kumar. So what exactly is pervasive computing? Recent technical advances in computing and communication have led to multiplication of devices embedding computational capabilities and is known as pervasive computing. These devices produce a vast amount of behavioral data. Emerging technologies such as augmented reality heavily rely on continuous video feed of the user's surrounding. AI or artificial intelligence system can exploit this data to learn more about users. Although it is said to be used for improvement of services, but it can also be used for surveillance, advertisement, and algorithmizing of behaviors. Nowadays, AI is being used in sensitive domains like justice, healthcare, and autonomous driving, where an erroneous decision can cause a lot of damage. The important question arising today is why we cannot trust AI. According to author, AI-assisted decisions are only as right as the data provided for training. Such data often reflects existing bias in gender, race, or religion. The resulting AI system will thus reinforce existing discriminations. AI systems rely on a continuous data stream for learning. Such systems may be hijacked by malicious users to alter their original purposes. A famous real-world example is Tay, Microsoft AI-powered chatbox, which started posting offensive tweets after interacting with Twitter users. Some of the techniques behind AI, such as deep neural network, boosting, and random forest functions as black boxes, making decisions without exposing the underlying reasons and preventing their application in the most sensitive domains. Then, with all the reasons listed in the last slide, is there a way to trust AI? Well, till date, human ethics can hardly be summarized by typical representations such as a decision tree. Transferring this human ethics into a clearly defined machine ethics rule set is thus an intricate problem. But author tries to sum up the trusting AI according to three components, such as ethics of algorithm, ethics of data, and ethics of practice. And these are well explained in the later slides by my colleagues. But for now, ethics of algorithm constitute of respect of human anatomy, prevention of harm, fairness, and explicability, whereas ethics of data contain human-centered individual data control, transparency, accountability, and equality. Ethics of practice contains responsibility, liability, code, and regulations. Next set of slides will be taken care by Arpit.
Hello everyone. Next part of this paper is trustworthy AI system. There are 7 requirements for a trustworthy AI. So in this section we discuss the current status of research and remaining challenges for each of 7 requirements. So the first one is human agency and oversight. So let's discuss the first subtopic, which is human in the loop AI. Originally, the human in the loop AI approach was proposed as a workflow where artificial intelligence learns from the human operator while automatically making the human's work more efficient. Active learning is one such approach where human provides label for some unlabeled data in order to achieve the desired accuracy quickly. So it can be utilized in designing AI system. This strategy has recently been used to create more equitable AI system concept, and that is AI system which generate revenues will repay the legitimate owners of the knowledge used for taking those decisions. Second is technical robustness and safety, in which let's discuss the adversarial artificial intelligence. AI models are susceptible to various kind of attacks, that that is poisoning attack, evasion attacks, and model stealing attacks. So current state of the art defense method against these attacks focus on increasing the robustness of the model by injecting adversarial example into the training set, hiding the model's information from adversaries, then reducing the sensitivity of the models by decreasing its complexity and minimizing the transferability. Then next is safe and reliable artificial intelligence. Reliability in artificial intelligence is ensured by borrowing three principles. The first one is failure prevention, second is failure identification and reliability monitoring, and third is maintenance. So to prevent failures in AI systems, the current state of the art methods try to proactively identify source of error resulting from bad or inadequate data, differences or shift in environment, then the model associated errors or poor reporting, and then develop methods that correct for this in advance. After deployment, reliability mechanisms evaluate the model output for each new input and reject the unreliable output based on the auditing criteria of the density principle and the local fit principle. So the model maintenance require detecting when updates to the model are necessary. However, unlike in traditional software engineering system, the maintenance cost is already compounded due to development complexity. Third is privacy and data governance. According to the privacy by design methodology, privacy issue must control the entire engineering process. It was originally designed for traditional software system. So in the context of AI systems, it involves seeking explicit consent from the data owners before using the data in training the model and respecting clauses like the right to be forgotten under General Data Protection Regulation GDPR. A regulation on data protection and privacy in the European Union and the European Economic Area whenever invoked by the data contributors. Fourth is transparency. Explainability in AI system requires the decision made by an AI system can be understood and traced by human beings. So explainability in traditional AI system is straightforward because the decision boundaries corresponding to these models are easy to visualize. Furthermore, explainability in deep learning AI system is not possible due to its non-linear structure, hence it known as black box models. So current attempts of explainability for black box models are focused on input attribution, concept testing, and example matching. Then communication. AI based chatbots like Google Duplex can mimic human sound so perfectly that even a human could not tell whether they are talking to a robot. Generative adversarial network can produce fake images which look real to human users. So transparency by communication emphasize that AI systems should not present themselves as human to users, and humans have the right to be informed that they are interacting with the AI system. So efficient solution to differentiate human initiate action from machine initiate actions are still remain unexplored. Next is diversity, non-discrimination, and fairness, in which let's talk about discrimination discovery. With the help of data mining and machine learning techniques, discovery aims at identifying discriminatory patterns in data, and it builds upon extensive research in statistics on discrimination evidence, addressing new challenges due to increasing volumes and complexity of data and ways of possible unfairness. Then discrimination prevention. Discrimination prevention develops methods for sanitizing algorithm or adjusting machine learning processes so that outputs follow the fairness limitation. There are several attempts to fix algorithm include pre-processing training datasets, post processing trained models or model outputs. Next is societal and environmental well-being. To address urgent social issues in the most environment friendly manner, computational sustainability requires the development and use of artificial intelligence systems. It involves minimizing environmental impact during training and development while consuming resources and energy efficiently. In smart cities, AI based transportation system plan efficient travel routes while minimizing greenhouse gas emission for commuters. Due to the widespread use of wearable and social media in our daily lives, We are constantly exposed to social AI system, which may change how we consider social agency or have an adverse effect on our social relationship and attachment. For example, algorithms managing the newsfeed of Facebook users may influence the user's political perception, and effective computing supports computers with empathy and giving emotional intelligence to machines. Last one is accountability. Data provenance methods track the flow of data from end to end across technical and administrative boundaries, thereby bringing accountability by providing evidence. For example, the method used to gather and process personal data, as well as improper actions such as disclosing personal information to an advertiser without authorization, includes data provenance. Then data auditing. Data auditing for AI system takes place during both development and deployment. During the development, software verification methods ensure compliance with regulation and company policies. For example, GDPR mandates privacy and data protection by design and by default, and that is seeking clear consent from users and applying the strict privacy setting by default. During deployment, blockchain technologies allow for the establishment of unchanging record that can function without the need for trusted third parties and preserving integrity. So from here, my other team member will continue with the presentation. Thank you.
Thank you, Arpit. Next, we are going to discuss ethics in trustworthy AI systems. AI systems differ from traditional decentralized systems in one significant aspect, that is, AI models revolve around data. It is one of the main reasons why companies with an active AI engagement, such as Google, Amazon, or Facebook, collect users' personal information pervasively. This data collection includes information actively shared by the user, but also a multitude of other parameters sensed by other devices. In return, users benefit from their services for free. But there has been abuse with the responsible and sustainable use of data. The Data Ethics, a Denmark-based politically independent think tank, recommends 5 principles, that is, human being at the center, individuals' data control, transparency, accountability, and equality to enforce data ethics. The ethics of data focuses on ethical problems posed by the collection and analysis of large data sets using AI or data mining techniques, which makes it possible to re-identify individuals while linking with other auxiliary datasets. With the advent of 5G, sensing and AI are becoming more pervasive, supported by edge computing, in-network AI, augmented reality, and the Internet of Things. This phenomena leads to the problem of ethics of sensing. Where can we place the logic that guides and governs the ethical behavior of a system or application? Or should some of the logic be in the sensor itself to prevent misuse? There are two directions that can enforce data ethics. A first direction lies in using design principles which advocate storing very little or virtually no amount of users' raw data. The other direction is letting users decide which data they want to share and even earn economic benefits. This approach aims to give control of personal data back to users. It can play a significant role in challenging the current status quo of surveillance capitalism, that is, the commodification of users' personal data and their transformation into behavioral data for analysis and sale. Zero knowledge as a design principle. According to the GDPR, no data must be stored longer than is necessary. Companies can go beyond this legislation and delete data before the required date. It can be done through auto-deletion but also by never having access to the data in the first place. Contextual integrity as a design principle. Many organizations collect data on people's lives and activities without their knowledge. The theory of contextual integrity allows enforcing data ethics by providing a framework for evaluating the flow of personal information between agents to identify and explain why certain patterns of information flow are acceptable in one context but viewed as problematic in another. Personal data boxes act as a single point or physical gateway through which users' data flows to anywhere outside the user's control. It allows users to capture, index, store, and manage data about them as well as data generated by themselves. Ethics of practices focus on the responsibilities and liabilities of people and organizations in charge of data. It aims to determine and maintain guarantees for the ethical use of data and models when disclosed as multiple stages and aggregated by multiple parties. To this purpose, it is necessary to define both a technical and ethical framework to guide decisions such as data release. In this paper, a framework algorithm is proposed for trustworthy AI systems in the age of pervasive data collection and computing. This framework provides a data-centric level of abstractions for ethical questions posed in the AI and data science context. This data-centric level of abstractions provides ethical abstraction at three levels, that is, data, algorithm, and practice. It basically focused on the ethics of data and ethics of algorithms, and more specifically, the aspects that can be integrated directly within the design and development of AI systems. That's the end of our presentation, and thank you for your attention.